Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 21 to 24 of the January 2019 Algebra 1 New York Regents exam. For access to the entire collection of tutorials, look to the description for the link. Do not forget to like and subscribe for updates to other series of these review tests. Alright, let's take a look at question number 21. Question 21 reads, it says, the functions f of x, q of x, and p of x are shown below. So this is f of x, the graph, q of x, the equation, and p of x, the table. Alright, so these are three representations of functions that you should know for Algebra 1 in order to do well on the Regents exam. The question is, when the input is 4, which function have the same output value? In this question, you're being assessed on your ability to read functions with a specified input. Can you determine what the output value is given a graphical, algebraic, or numerical representation? Okay? Alright, so we're going to attack them one by one. We're going to start with f of x. F of x is the graphical representation. So this is a graph that we have right here. Alright, so when we're dealing with graphs, how do you determine what the output is with a specified input? In this particular problem, the input is 4. So if the input is 4, we automatically know what x is. If the input is 4, the input is x. Okay, so x is going to be 4. Now for graphical representation, we're going to be plugging 4 into this table right here. So that's going to be f of 4. So what does f of 4 mean? F of 4 basically means what is the y value associated with the x value of 4. Alright? So f of 4 is the y coordinate. The y coordinate when x is equal to 4. Okay, so what is the y coordinate that's associated with x equals 4? Basically, what is the ordered pair on this function? What is the y value of the ordered pair on this function, or the point on this function when x is equal to 4? In order to accomplish this, all you just do is carry out your vertical and horizontal traces. Okay? Alright, so since we're starting from the input, or the x, we're going to be doing the vertical trace first. So let's go ahead and do that. Alright, so our vertical trace will start from the x value of 4, 1, 2, 3, 4. So vertical trace, you just trace upwards or downwards to the graph of the function. Okay? In this case, the graph is above, so we're going to start from 4 and trace to the function right there. That's too thin. Let me make it a little bit thicker. Okay. Alright, so we start from 1, 2, 3, 4. You trace it up since the function is above, and then you hit a point. Okay, now that point that you hit is an ordered pair. Every point on the graph has, on a two-dimensional graph, has a x coordinate and a y coordinate. Okay, so when you trace this value of x equals 4, which is the input, okay, when you trace it to the graph, you hit a point. This is a lattice point right here. Nice, pretty point for us. This point has the x coordinate of 4. How do we know that? Well, that's where we came from. Now, what is the associated y coordinates? 1, 2, 3. If you draw a horizontal line from the desired y coordinate to that point, then you're going to see what we want. So the y coordinate, if you start from this point and you go straight to the y coordinate, you're going to be at the y value 3. Alright, so the ordered pair that's associated with x equals 4 is 4, 3. Alright, so the question is, what is the output when the input is 4? So 4 represents the input, and guess what the output is? The output is the y coordinate that's associated with it. So this is your output value, which is 3. Okay, so from this graph, we can clearly see that f of 4 is equal to 3. Alright, Now let's move on to the other representation. Let's deal with the algebraic. Alright, so we have algebraic representation. We have an algebraic equation here. Now for this scenario, we want to look for Q of 4. Okay, notice we're replacing the x with 4 because that's the specified input value. So Q of 4, what is Q of 4 in an algebraic representation setting? To get Q of 4, all you do here, slightly different, is you're going to substitute the input value 4 for the x's for x in the equation. Okay, substitute 4 for x in the equation and simplify. And that's all you have to do. Okay, so what equation am I talking about? Well, is the equation that we're given here. Q of x equals the quantity x minus 1 square minus 6. So we're going to take out all the x's. Let's take them out, parentheses, and then we're going to replace it with 4. Alright, so Q of 4 is going to be 4 minus 1 quantity squared minus 6. Okay, now how do we simplify this expression to the right of Q of 4? We're going to use the order of operations. Please excuse my D and Sally, okay? So we have parentheses here. We're going to deal with that first. Whatever is in the parentheses, we have a difference. So 4 minus 1 is 3. 3 squared minus 6. Okay, so using the order of operations, do we subtract first or do we do the exponent? We do the exponent first, right? So 3 squared is 9. 9 minus 6 is equal to 3. Okay, so for the algebraic representation, this algebraic equation here, Q of 4, the output when x is equal to 4 is 3, the same as f of 4. Alright, so the last one that we are going to look at is the tabular representation. What if you're given a table? That's another way that functions can be presented. Okay. Alright, so for tabular, this one is the easiest one to do. You don't have to do much work. For tabular representation, we are looking for P of 4. Okay, so what is P of 4? P of 4 is just the y that's paired with x equals 4. So y value paired with x equals 4. What am I talking about? 2 is paired with 5, 3, 4, 4, 3, 5, 4, 6, 5. You have the pairings happen horizontally here. So for x equals 4, what y value is paired with it? It's paired with 3. So what does that mean? It tells us that P of 4 is equal to 3 because this is the output or the y value that's associated or paired with the input or x value 4. Okay? Alright, so the question again says, which of them have the same output value? What's your answer? For the graph, the output was 3. For the algebraic equation, the output was 3. And then for the tabular representation, the output was 3 also. So guess what? The answer to question number 21 is option 4, because all three of them, f of x, q of x, and p of x, have an output value of 3 when the input is 4. Alright, let's take a look at question 22. In question 22, we're being assessed on how to solve systems of equations by substitution. Okay, the question reads, it says, using the substitution method, Vito is solving the following system of equations algebraically. So y plus 3x equals negative 4, 2x minus 3y equals negative 21. The question is, which equivalent equation could Vito use? Alright, so when you're solving systems of equations by substitution, there are 3 steps you want to keep in mind. Okay, so let's write steps for solving. Steps for solving systems by substitution. Okay, alright, so first thing you want to do is you want to isolate. Alright, you want to isolate a variable from one equation. Okay, isolate, And the next thing you want to do is you want to substitute what you isolated in the next equation. Substitute. And then 3, you solve. This solve process is two parts. You solve for one variable and then you substitute it back into the other and solve for the other one. Okay? So just think ISS to solve systems by substitution. Isolate, substitute, solve. Alright, so as we are executing these steps, we're going to see what the correct answer is. So let's do the first step, which is to isolate. Okay? So step 1, isolate. Now, for the isolation step, we're going to take a look at all the variables here. There are 4 of them. And then we ask ourselves, which is the easiest to get by itself? In most cases, the one that has a coefficient of 1 is normally the fastest to be isolated. Okay? When you have a sign or an integer, a coefficient that's not 1, you have to divide. So that's a division step. But when you have a coefficient of 1, that variable is the easiest because you do not have a division step associated with it. So if you look at y, this y in the first equation, let's label it. So let's call this 1 and call this 2. So in equation 1, y has a coefficient of 1. This is the variable that you want to isolate. Why is that the variable that you want to isolate? Because it's the one that can be isolated with the fewest number of steps. Remember, the shorter you can make your work, the less likely you are to make mistakes, and you save time too. Alright, so that's the strategy we're going to use here, and that's the same strategy that Vito used. So we're starting from equation 1. What do we have? From equation 1, we have y plus 3x equals negative 4. Our goal is to isolate y, get y by itself. So to isolate y, we will subtract 3x from both sides of the equation. And that yields y equals negative 3x minus 4. This is equation 3. Ladies and gentlemen, we have achieved the isolation step. The isolation step involves getting a variable isolated all by itself without any coefficients. Now step 2 is to substitute. Okay, now we need to remember where 3 came from. 3 came from 1, so we're going to substitute 3 into 2. We can't substitute it back into where it came from. You have a circular definition. You're not gonna get anywhere with that. Okay, so what are we about to do? For the substitution step, step number 2, which is to substitute, this is what you are going to do. We are going to substitute this value, negative 3x minus 4, for y in the other equation, namely 2. Okay? Alright, so let's go ahead and write down equation 2. What is equation 2? Equation 2 is 2x minus 3y equals negative 21. Okay, that's equation 2. Now what we're going to do is substitute. Okay, so let's call this equation 2. We're going to substitute this into equation 2. So to do that, what we're going to do is take 3x minus 4 and plug it into the y spot in equation 2. So what results after that? When we execute that step, we're going to have 2x minus 3. Instead of y, we're going to replace it with the y value that we got from equation 1, which is negative 3x minus 4 equals negative 21. Let's freeze right there, because it looks like we have a format that's similar to what we have here. Okay, so upon the substitution step before simplification and solving, let's see if we have a match. 2x minus 3 times the quantity negative 3x minus 4 equals negative 21. Ladies and gentlemen, the correct answer, or the equivalent equation that can be used to solve this equation, is option number 3. Okay. Alright, let's take a look at question 23. In question 22, we looked at how to solve systems of linear equations. In question 23, we have a system of exponential functions or equations that we want to solve. Okay? Question 23 reads, materials A and B decay over time. So we have exponential decay here. The function for the amount of materials A is A of t equals 1000 times 0.05 raised to the 2t. And for the amount of material B is B of t equals 1000 times 0.25 to the t, where t represents time in days. On which day will the amount of material be equal? Okay? So when we're looking for the day when the amount of materials are equal, what we're looking for is the intersection of these two functions that we have right here. Okay? Alright, so let's go ahead and write down what we are going to do. So the time when amounts are equal is when A of t is equal to B of t. Okay? So basically, if we want to do this graphically, what does this mean graphically? Graphically, we find the point or points of intersection. Alright? Where do these two graphs intersect? Wherever they intersect, those are the times when the amounts are equal. Okay? So what we're going to do is we're going to graph these two functions, and we're going to see what the point of intersection or points of intersections are, and then that will be our final answer. Okay? Alright, so for the first one, we have 1000 parenthesis 0.5 raised to the 2t power, so just use caret 2t parenthesis 2t. Since you have 2 and t in your exponents spot, we want to put parentheses so we do not have grouping errors. Okay, so as you can see in this button right here, that button represents x, t, theta, and n. So when you're graphing, it's a function of x, so the x is what is used in place of t when entering it into the calculator. Alright, x and t are your independent variables, and they're interchangeable. Alright, so for the second equation, we have 1000 parentheses 0.25 raised to the t power. So t in this context is just x. Enter. Alright, so we want to look for the intersection of the two. So let's do a standard zoom. Zoom 6. So there goes the first one. And where is the second one? Where is the second graph? We had the first one, and it looks like the second one is either the same as the first one or somewhere else. So if you have a situation like this, one thing you can do is you could do this. So what I want to do is I want to show an animation. I want to show a pathway that the graphs followed. Okay, so just in case we have an overlap. So here, instead of line, I'm gonna press enter, 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 enter. So it's gonna show a ball, a little circle sweeping the path of the graph. And then here, the same thing. Instead of just a line, it will be a line and a circle showing the pathway that the line passes through. Alright, let's graph it again. So check this out. So you're gonna see that right there. So that's the first one. You see where the first one is. And then, ooh, the second one is exactly on top of the first one. They are one and the same. Another way you can look at this to see that they are actually the same graph is to consult the numerical representation. Just go to the table. And what you notice is that y1 and y2 are always the same. Always the same. So how many times do they intersect if they're always the same? They intersect at every point in time. You have infinitely many solutions, okay? So let's go back to the question. For what days? For all days, okay? Since we have infinitely many intersections for all days, the quantities are the same, or the amounts are the same. So the answer to question 23 is option 4, because we have infinite number of intersections. They are actually the same function, okay? So that's that. Alright, let's take a look at question number 24. Question 24 will be assessed on how to convert units. Question 24 reads, it says, the following conversion was done correctly. And the question is, what were the final units for this conversion? Okay, so what we're doing here is we're trying to cancel out units that cancel out and see which one is left. Alright, so basically the cancellation procedure is any unit that's in the denominator can cancel out any identical units in the numerator. They do not have to be adjacent. Okay, so what am I talking about? For example, look at the unit miles, for example. Okay, mile or miles. This is in the numerator, this is in the denominator. Okay, identical they are, so guess what? They divide each other out. The reason is that multiplication commutes, so this 3 miles could be moved over here. Doesn't really matter because it's a product. Product, so you can commute the conversion factors. Alright, so miles cancel out, so miles is not in the answer. Oh, we have hour in the denominator and an hour in the numerator position. They divide out. And then foot and feet are the same thing, just plural and singular. These two divide out. And we are left with inches per minute. Okay, so the final unit is going to be inches in the numerator. Let's write that again. Inches in the numerator divided by is per inches per minute. Okay, and the answer is option number 4. Thanks so much for taking the time to watch this presentation. Really appreciate it. Let us know what you think. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions, comments, or special requests, post it in the comment section below. We'll be more than glad to respond. Don't forget to subscribe for updates to other presentations to get you ready for the Regents exam. More support resources can be found by referring to the link in the description, or just go to mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.